Good afternoon, everybody. I'll be doing a small revision on statically determinate structures. As you already know, we have three equilibrium of, equation of equilibrium, which are summation of horizontal forces to be equal to zero, summation of vertical forces to be zero, and summation of your moment to be zero. Now, let us look at all these members, their support condition. As I explained earlier, I said we must know the expected reactions at each support. For instance, if we are considering a cable, we should know that we are expecting only one unknown, that is only one reaction in that particular cable. And if it is roller, it is only one unknown. And if it is hinge or pin, we have two unknown. And when we have a fixed support, we have three unknown, that is the force along the x-axis, the force along the y-axis, and the moment about the support. Now, let us look at a simple equation that will help us to know whether a structure is statically determinate or not. For instance, when we say let us consider n to be the number of the total number of parts in that particular structure, and r to be the total number of unknown reactive forces and the moment component. Now, if we have an equation like this, that r equals to 3n, that means the structure is statically determinate. That is, when you have 3 times total number of numbers to be equal to the total number of unknown reaction. However, it is possible for us to have r to be less than 3n or to be greater than 3n. In this condition, when we have r to be greater than 3n, that means the structure is statically indeterminate. And when it is less than 3n, that means the structure is unstable. Now let us go to example. Looking at this particular beam being supported on a roller support at one end, hinge at another end, and having an overhang like this, and this, and this, and this. Now let us look at the first one. For this particular one, how many members do we have? You can see we only have a single member here. So here, our member n equals to 1. Now, how many supports do we have? We have 2 supports here. So, and I told you earlier on that when we have a pin or hinge support, we are going to look for 2 unknown reaction there. And when we have a roller support, we have 1 unknown reaction there. So for this particular one, we are supposed to have 2 unknown reactions here and 1 here, making 3 altogether. So our reaction is 3. Now let us start using the equation r equals to 3n, where our r is the reactions. How many? We have 3 reactions, and what number of members do we have? We only have 1 member. So r equals to 3n, as we have it. R equals to 3 times n. So since this is equal to this, that means the structure is statically determinate. Now you can see this arrow is indicating the number of reactions or non-reactions that is applicable at that particular point. And likewise this one, that's for the one at the roller support. Now let us look at the second member, which is this. Now this one, we know that this one is fixed here and it's having a roller support here, a roller support here. Now what we're going to do is that, how many members do we have? We only have a single unit 1 member here because it's not hinged, so it's only a single member. Now let us look at how many r do we have. I said we have 3 for a fixed support, 1, 2, 3, and we have 1 for a roller support, making 4, and another for a roller support, making 5. So for this particular one, we're now going to check r equals to 3, and what do we have? Now for this particular one, our r equals to 5 minus 3 times n, which is equal to 3. So if we do this, we have 2. What it means is that this structure is statically indeterminate, and this 2 that we have here is the degree of indeterminacy. That is, it is statically indeterminate to the 2nd degree. Now let us look at another very wonderful structural member tilting in this direction. Now looking at this, so somebody might be thinking maybe we have a single 1 member. No, we are having 2 because it is hinge at this joint. One is hinge, that means this second part can move freely irrespective of what is happening to this particular member here. So for this particular one, we have 2 members. How many what's it called? How many reactions do we have? For this particular one, it's very dicey because we have a kind of fixed and roller support. And when we have a fixed and roller support, and as we have here, there's something that is, and there's something, let me say, we cannot treat it like a fix. We can't treat it like a full fix, because a full fix member is supposed to have three unknown reactions. But for this particular case, this one has only two unknown reactions. That is for movement and the vertical, let me say, horizontal movement. Now, it is restricted about fixed and horizontal movement. But however, this hinge that we're having here is having, I told you, a hinge support or a pin support has two unknown. So when we add 2 plus 2, making 4 already. Now this is another pin support, making 2 reactions. So the total number of reactions is 6. But how many members do we have? We only have 2 members, 1 and 2. So when we do the calculation, is R equals to 3n? Let us do it. R is equal to 6, equals to 3 times our number of our member number, which is 2. So 6 is equal to 6. That means this structure is statically determinate. Now let us go to another beautiful example. Look at this structure. We have it fixed here, and 2 hinge at let me say at various points here. Now for this particular one, the same thing that we did earlier on is what we are going to do. For this one, we are going to look at how many unknown reactions we have. We have 3 here, we have 2 here, we have 2 here, and we have 3 here. So the total number of unknown reaction is 10. 3 plus 2 plus 2 plus 3, making 10. But how many members do we have? We have one member here, another member here, and another member here, making 3 members. So let us check whether our structure is statically determinate or not. We use our formula R equals to 3n to check. Now looking at this, R, when we say R minus 3n, because this is R minus 3n, 3 times 3 making 9, 10 minus 9 making 1. What it means is that this structure is indeterminate and to the first degree. So that is all about that. I will want us to try a simple example on this. I will send it to the class so we can always check if we are able to get it or not, and I will send the solution as well. Maybe after I will send the solution after you must have tried it. Maybe I will send it after maybe an hour, so to see what you have. So have a lovely, wonderful day.